work on data stacks on Cassandra. So what that essentially means is that I spend most of my life alone in my shed, just me and the dog, which is fine because it's a pretty sweet shed. But she's not a great conversationalist, so it's a cliche, but I've done more talking in the last 2 days than in the previous 2 months. So if I run out of vocal cords before the end, you'll just have to read the slides. Okay. So what I'm going to talk about is SASI. We'll just give a bit of an overview. I'm sure everybody is kind of aware of what SASI is. Some of the people that developed it initially are in the room, and they're not me. So that's a bit awkward. But, so I'm just going to talk a little bit about the progress that we've made with this in the last sort of 6 months or so, really. So SASI is SSTable Attached Secondary Index, the new and improved index implementation for Cassandra, which has always been kind of pluggable and an extension point, and lots of people out there use it to great effect. But Cassandra ships, as we all know, with a default implementation. And SASI really, if I've understood the motivations correctly, is kind of a wholesale, how would we do this if we knew all the things that we did wrong the first time? And it was developed at Apple. Pavel and Jordan presented it here last year as a sort of proposal that, to integrate this into the mainline. And that's what's basically been happening since then. So the key being the clues in the name, the indexes, in contrast to the original secondary index implementation, the indexes are an integral sort of component of the base table. So Josh mentioned earlier that there's sort of bad things that happen when you use tables to do other things, other tables. So indexes is a great example of that. There's a number of things that it does better or more flexibly than the original implementation. So indexing on the right side, it brings in a lot of sort of full text analysis concepts like tokenization, normalization, all those good things that we didn't do originally. And then on the query side of things, it gives a much more expressive and sort of powerful query syntax. So including search type operations like prefix matching, suffix matching, range queries over numeric values, and logical operations. So I stole this directly from one of Pavel's slides, and this is the kind of complex sort of queries that we can do. This isn't a contribution, by the way. And sort of a really key feature that's not immediately obvious from that sort of thing is that you can actually leverage multiple indexes in a single query. So with the older implementation, it's really some crude heuristics that are employed. Even if you've got indexes across every table, every column in your table, and you're going to put conditions on those, Cassandra will just try and pick the best index, look up in there and filter everything else against it. Whereas with SASI, you can actually employ the indexes that you've got more efficiently, intersect across or union across those lookups. So that's a kind of killer feature. And this is its history. So the original version that got open source was built against a kind of lightly patched 2.0 version, and that was open sourced in November last year, following the presentation that the guys gave last year. And it was open sourced as kind of a standalone sort of project, so you can build it, patch your Cassandra, build the jars, drop them in, and away you go. But we obviously wanted to get that into the main line and make it more accessible. And the first version that shipped, first version of Apache Cassandra that shipped with that was 3.4. That shipped in March of this year. And one of the things that made it a lot more challenging task was that there was shit ton of changes to the indexing subsystem between 2.0 and 3.0. And in some ways that was real pain in the ass, but in other ways it was quite good that it was going on at the same time, because it meant we could inform those API changes somewhat with what was going to come with SASI. So it just made the integration a bit less straightforward than it could have been perhaps. But because of that, we decided to take this sort of phased approach to that integration. So first step was to port the real core of the code to 3.0, and the intention for that was to give us the bulk of that functionality. So what it really gave us was the search type features. It gave us the improved building of the indexes because it became part of the regular SSTable generation. And it gave us a little more flexibility with the queries, really, to be honest. The second phase, which is kind of what's going on now, is to bring across the improved query planner from SASI, which is what kind of delivers that logic and that Boolean logic in the where clauses, and does the more efficient index usage. So that's kind of in progress right now, and then it gets more hand wavy as it gets into the final phase, which is to try and go further and have more complete collaboration with different index implementations, so that we can hopefully do that kind of intersection work with non-SASI indexes as well. But that's kind of like it's a bit of a dream at the moment, so that may get broken down into further pieces as we get further into it. Like I say, that first phase is kind of complete, and this is where we are today. So we've got all the code in place to generate the SASI indexes when we write or when we rebuild SS tables during compaction or after streaming or on flush or whatnot. Made some reasonable modifications to the way that indexes get built and rebuilt, because essentially SASI wants to build all its indexes at a single time by a single pass through the SS table. And we kind of had to change the way that we worked to shoehorn that into working with all the existing index implementations out there. And then finally, there's been some minor changes to the CQL syntax, mostly to accommodate the like operator, which is used in a containers kind of match, partial word matching queries. There's going to be further CQL syntax changes coming in the not too distant future, because we're going to introduce the OR operator and things like that. So there'll probably be more impact in the next couple of months. But right now, it's been kind of trivial. And since the initial integration work, we've closed out 20 JIRAs, which are either improvements or bug fixes. So SASI was running at Apple for quite a long time, I'm led to believe, in production, and was highly back tested and very, very stable and robust. But that was the 2.0 version. So although conceptually not much has changed in the version we have in Apache Cassandra, implementation-wise, there's a whole lot of things that have changed. So what we've got is obviously nowhere near as seen as anywhere near as much of a deployment as the original version. So some people at DataStax, Ariel and Duhai did an awful lot of work in the lab hammering on this thing, and a large proportion of those 20 improvements and bug fixes came out of that work, which was pretty awesome. Obviously, there are some limitations where we are now because it's incomplete, but I'll just skip through them real quick. Like there's no support for indexes on collections or partition key components, which is obviously a regression from what we have right now. Due to the design of the data structures, it only supports long tokens, so you can only use it with murmur-free partitioners. So sorry about touching no box at the moment. There's some vestigial syntax ugliness, which is essentially things like allow filtering. So although, like I say, we can make use of all the indexes that are there on the table and exploit them as fully as possible, you still have to tell Cassandra that you want to allow filtering. This is just purely at a syntax level, because it needed some serious surgery to fix that, and we just wanted to kick that down the line a little bit. There's some baggage with it being known as a custom index implementation right now. So again, that's mainly inconvenience and ugliness. But it serves a kind of a purpose as well, because really this is, I would call this an experimental feature or an incomplete feature right now. So just keeping it demarcated as a custom thing should set off a few warning bells in people's brains before they start throwing this into their production systems right now. So that will go away eventually, but it's there right now. And then this final point is kind of more of a major thing, and it's the root cause of some of the other limitations. So the way a SASI index works is that it's essentially a lookup from an index term to a partition key. So when you find the matches, that allows you to bring back the partitions that contain rows which match those conditions. So then you have to filter all the rows. You have to iterate through the rows in that partition and filter the ones that don't match your condition. So that's kind of an inefficiency that's a holdover from the original design, which came before this was like the main accepted way of working with things. Predates CQL basically. In progress right now, Pavel's working on this as we speak. 10.765, which is going to add back in the support from the original, the functionality from the original SASI implementation for those complex workloads, and bring in the optimizing query planner, which is some really cool stuff, and really probably the first query planner that Cassandra's ever had. So it's kind of nice to get one there, and that's going to take away that allow filtering requirement, the vestigial syntax ugliness. We're targeting this for 310, the 310 time zone time frame. So, but it does involve some of this major surgery that I mentioned earlier at the CQL level. So it's going to be a push, but I think we'll be good to get it for 310. And then the future of this kind of stuff. Basically, we obviously want to remove those limitations. That's the key thing. So collections and UDTs for the partitioners, we need to address those. We'll have to fix the limitation regarding filtering and fixed size data structures in the thing. So hopefully there's some lessons from Birch that we can take across there. And the key, the real thing that will be the winner is some collaboration between the different index implementations. So this is kind of hand wavy as well. We don't have a clear enough plan for this right now, but it's going to involve some further changes to the index API. Sorry guys. To allow index implementations to expose information about how they can be used in conjunction with each other. So it would be great to be able to have, say, a Lucene index on one column or it's one set of columns, and some SASI indexes on other columns, and write queries that just exploit them to their fullest, and have the intelligent query planner figure out the best way to actually execute that. And that's the real goal we want to get to with that. So, but that's going to be some way off at the moment, I think. And then the last thing is I think we want to make SASI the default and take away the custom signifier around that. So when you create an index on a column with Cassandra without using any custom implementations, it should be a SASI index, really. And the open question we've got there is whether we want to retain the legacy implementation as well. It's kind of overhead and maintenance and all that kind of bad stuff, but I don't think we've really thought hard enough yet about whether it is the right choice for some workloads or some particular use cases. So we need to do that. And that's pretty much all I have. That is the future. So thanks very much.